technology as it is a development, but for some clients and some expectations that were not met due to these fake news. I'm sure that you've heard, all of you, 3D printing is cheaper, it's faster, we can print everything, we can print everywhere. We can print a house in 1 week, we will print thousands of villas. And all of these statements have been heard, unfortunately, and not always by the providers themselves. So that has been, I think, pushed a bit clients into big hope and linked with it quite some despair. So with the technology from the R&D, the climb has been extremely quick, and we had very quickly support from the government, people interested, client that wanted to do 3D printing, all the consultants involved and wanted to come to us and say, okay, how do we do? What do we do? Where can we do something? And then we started to do some projects. And honestly, the first projects were quite amazing. Unfortunately, they have been partly misunderstood. This one is a very famous example, one of the first, and the first probably here in the region, Dubai Future. And unfortunately, in the image of client and probably worldwide, people thought that this piece was fully 3D printed, where in reality, well, it's still concrete, right? And concrete is not able to take tension. So when you start to do building or elements like these, well, it is much more complex than some people thought. And in the start, where they just jumped into it, well, they soon realized that they had to add manually some reinforcement, that they had to come up afterwards with joints, with non-shrinking elements, with post-tensioning. And all of these elements, if you look at the details, obviously are far from our dream of just 3D printing a building. Also, a lot of finishes efforts needed to be made. So you can definitely imagine that between the expectations and the reality, this was much more complex to be executed. We kept going, and in the region also, Dubai municipality has built the biggest concrete 3D printing building, 2 levels. And that is a tremendous achievement. Again, partly misunderstood, because these buildings have to be still with the common traditional reinforcement to be able to get all the load bearing. So within that building, as soon as you go out of the 3D printing part, well, obviously you enter into a whole more complex system, and then you needed still to find a lot of details to be able to incorporate windows and all the other elements. I think that's very important to understand for people, that you still need sometimes, in some cases, traditional within the element. It was the same with the first bridge that was also supported by TU Eindhoven. And there for the bridge, it took also more time, but the difficulty was the volume that was used for the project. We didn't know fully the quality of the material, and physical testing has been made. There are very interesting articles about it. And basically, we have been very conservative, or they have been very conservative in the design itself, because it was the start of the technology. So another big issue is that we said we can print everywhere. Well, in the beginning, the material was not able to sustain the environment, and some of the first printing had to be within a tent, had to be in controlled environment, and some of them had quite some issues in terms of cracks. Again, you are disappointing a bit a client that thinks that everything is running, even though this is still pioneering. Same with the quality. You expect 3D printing to be smooth and to be beautiful. Well, not always, and it depends on the applications. I think, again, this was in the beginning something that created a bit of disbelief. So unfortunately, and that's what I believe, due to that kind of misunderstood or expectations that probably were too high, we started to have quite some question. Is it really a good technique? Is it really something that is fast? Actually, it's not. It's much cheaper. So, we enter really that trough of disillusion, and that was amazing for people to just jump on it and start criticizing the technology. We have hidden costs, we have problems, we have, we will, and people were still on top of it saying, no, we are able to print hundreds of houses or 10 houses in 24 hours, and don't worry, everything will be fine. Well, that has cost the technology quite a lot. And that's something that we should, I believe, try to avoid in the future. So now, on top of it, and I think that's overall in the market, but on top of it, coronavirus hit us. And when you are a new technology and innovation, well, the pandemic is not the best. A lot of companies have seen cost cutting, a lot of projects have been put on hold, and that has also created some disbelief or people turning a bit away from 3D printing. That's the feeling for me last year, that we were quite down that curve. And today the question is really, are we out of that pioneering, and are we now ready to climb the curve and come back to a technology that will soon be more and more adopted and demonstrate its benefits? And I think for that, we should go back to the basics and really think about why 3D printing has been brought. We have some major society challenges. You all know population growth. Population is not going to stop growing, and we will have to build more and more houses in the world. We have also environmental issues, and the whole industry, supported by digitalization, is also looking into sustainability. So 3D printing with its specifics are able to answer some of these society challenges. I will not go through all the opportunities, but the challenges are still there, that it's still an investment, it's in a new technology. And there are some other points like regulations or experience that needs still to come more and more. In terms of advantages, if you look a bit more into detail, in terms of sustainability, yes, it requires less concrete for the same type of wall. Obviously, this concrete is cement. So in terms of volume of cement, it is wrong to say that 3D printing is going to bring way less concrete today. But you will see a bit later on in the presentation that still in terms of sustainability, we have just mixed powder mixed with water, and we are consuming less water, and the aim is at the end to consume also less cement. We are also avoiding to have molds, formworks. This is just based with a robot and without any formwork. That is quite a big advantage also in terms of safety, in terms of labor. Now, on the traditional method, you have quite some wastage if you go on the site. Well, with 3D printing, we are controlling that waste. It's extremely limited, or it can be reused. I think that's also quite an interesting one. And then you have other advantages. You are able to generate less dust and noise, and you have your system that is in a certain area quite controlled. Now, in terms of pollution, also, as I said, you are controlling basically where the concrete is going, and that limits a bit the cases, as you see there on the right. So there are really noble aspects within the technology, and I think we should never forget them, because these are today in the world quite important. And that's why I believe that we have an opportunity to come up the slope and go back to something that is productive and to a real product on the market. On top of that, obviously, we have had quite some improvements and a kind of a second or third generation of projects, which is clearly demonstrated for me that we are coming into that slope. Some of the projects to go quite quickly, but it's just to show you that the scale and the speed have tremendously improved. Even though there has been some disappointment on the speed before, now we are able to print quicker, and we are able also to improve the quality and to do things bigger. So the scale, this is just for buildings, of course, but has improved. Now, as I said, the speed, but also the quality. So if you look at the material, we have quite some people today, and we have our partner here in the region, with which we have developed a specific material for the region, SICA, that have done a lot of efforts on getting a material that is today, as you can see here on the picture. You have people like Apiscore on the left that have worked on the material and on the printing process to try to get smoother lines, to try to get smoother walls and not see really these bubbles or this layering system. They are not the only ones, but we are able today to achieve overhangs, different colors, different systems, and a very thin, precise printing. I will not go into the different system. For example, SICA has a one component or a two component system. These are things that I'm sure that you can go and look for yourself, but these are explanations of why you see some differences in qualities. It doesn't mean that the concrete itself is from a lesser quality, but it's just a visual also that is impacted. Obviously, the printing path on a house is much longer, so it has to be a bit faster, and the properties of the material are a bit different than if you are just doing a small piece with a very quick overhang. Now, there are some projects, again, in the region that have been pushed by very big partners. These projects, these ones have been put sometimes in the press, but it is not released yet in Dubai, so I will just skip it. But you are sure gonna hear from it very soon. And now, another very important point is that we get to have today the first inhabitants. Projects in the US, project in Holland, like the project Milestone here, and also in Germany. Some of these projects today are completed to a stage that these can be sold and used, and people actually living in. And I think that's a very big step when you see interiors today with all the details that feel quite comfortable as a house. These are two different houses, but you see that all the elements are quite well integrated within the house itself. Now, we are also printing easier outdoor, also linked with material, and also in remote areas with, again, a very good aim for the planet. Here it's to support regions that are in difficulty, where we can come up, and you know that in some regions they don't even have schools. So this is an example for me where we are doing good again with the technology. Now, on top of it, obviously the printing process has been improved. We have improved in the pumps. Pumps were first from plaster company, and they have been now really pushed towards 3D printing. The robots have improved. Now the robots can move. They have been reinforced. The length has been extended. The printing heads have been changed. And we also developed, for instance, the start and stop. So before you had to start printing and it was continuing. Now in some of the process, you can actually stop and start when you want. And that is more and more controlled. So you are able to achieve better ships. On bridges, we have also had tremendous efforts. This is in Holland. It's again the same team as the first bridge I showed you. We have improved in terms of testing and in terms of material, in terms of optimization of material use. And we've also improved in all the system of placing. So it's connection between the elements. You have quite a big logistic link to these projects. But once the logistic is in place, well, the placing goes quite fast. And as you see here, the bridge is quite a nice result. Again, as I said in the beginning, I'm not naming all the partners involved in these different projects. if you go online, I'm pretty sure you will find them. Everybody is named a bit later on, so don't worry. Now, talking about some big names, this has been also recently developed. ETH in Zurich is also one of the university that is pushing the technology quite a lot. And with Zaha Hadid architects, I'm sure you know as well, they have pushed to get what you see here, which is just a masonry type bridge. So it's bearing elements, so you don't have within the elements here additional traditional reinforcement. And obviously they needed to have a former to achieve it, but still in terms of completion of that bridge, I think it's also a very good step forward in terms of the opportunities, let's say, with the development. Again, another very nice initiative for homeless in the US. The company Icon has been able to put in some houses quite quickly. And if you look at the quality again, these have quite improved compared to what we were doing 2-3 years back. There are also other applications. This one is here in the region, and it's 2 buildings basically done fully with the facade system in 3D printing. It's similar to a GRC system. So this facade is not bearing, it's just basically hooked on anchors. And you can see here a very clear application where that element is very similar to another element that we are using in the construction business, which is the GRC. And also in terms of productivity, we have printed, I think there were more than 300 panels in about 2 weeks. So it goes extremely quickly again for these applications. And then you get, I think, still very important applications because it pushes the technology a bit further. Some art cases and some specific, very specific shape. And on top of that, you also have some elements that we call urban architecture or even inside furniture. You see here, and I'm sure you've seen some benches, here it's a picture from the expo. Actually, this is quite recent, a project we've done where all the trash bins and all the planters were done with 3D printing. And you see again, we are able to integrate other technology. So here you have lighting, you have irrigation systems and all of that. So all of these elements today you will find on the market, and they are getting more and more shown and used. And I think it's quite important also to have that element aspect in mind instead of having full project in mind. Now, I said it, I tried here to show you a bit how the community is growing and what are the major contributors worldwide. So you have in there, obviously, people that are focusing on materials. I talked to you about Sika. Sika has really pushed a lot the technology and has come up with, materials that are very interesting. You have other people also focusing on material like Weber, Saint-Gobain, and Lafarge, obviously. So I'm not going to name everybody, but you will see here the main actors and basically also people that you will find back more and more online on projects. Now, I will go through a case study because I think it's quite important for if you are not really familiar with how a 3D printing project works. Well, a classic project, let's say, you have an architectural intent or a client ID. And the first thing that you do, you look at the feasibility and obviously you try to get a budget out of it. Once you have that setup, well, you try to have a design. Obviously, that has to be as per the regulations. You integrate all the different trades, structural, MEP, geotechnics, you name it. And into that, you start the process of the project. You have material, you test your material, you explain how you're going to do it, you get the approvals, drawings, and then you do the execution. Now, for a 3D printing project, Well, surprise, it's exactly the same. So there is nothing much different in the way you guys are used to apprehend the project. And basically, it goes through all the same stages. Now, what is true is that for 3D concrete printing, we still have some like here and there. I think there are three main aspects that I will talk about a bit later on, is where it's a bit still difficult, is how do we do all the design as per the regulations? How do we test the material to make sure we understand its behavior? It is concrete. Inside the material, you don't see all the layering, but there is still a printing process that has an impact on the material quality in terms of design. And then how do you get the approvals to make sure that you are not starting to print whatever and having issues? So this is an example, also has not been published fully yet, but it's basically a house, Meulewaeter house on a golf course, where we came up with an architectural intent that was existing, and we've been approached to ask, okay, guys, can you do something in 3D printing? We want something that stands out and that people can recognize. So how did we approach this? Well, as any other project, so we tried to design in terms of elements and try to think about what were the different opportunities for this project. It is a small project, so we were able to push again a bit further the approach, and we went with fully load-bearing wall to try to get rid of that traditional reinforcement throughout all the pieces. And we've done a design. We were supported by AECOM. We've done a design according to the ACI for plain concrete. You have the same principle also applicable in Eurocode, and the rest was also done according to the ACI. So how do you calculate the loads, the wind, the seismic, and everything? And we've made, again, a design according to the codes. Now, the only difficulty sometimes in some projects is that the design itself or the code itself is not really validating your project. And for that, you always have a way out. And the way out is by physical testing. So you can do a mock-up and do trials to demonstrate that you are reaching basically your characteristic values that you are considering into your design. So you see on the right-hand side how for this small project, all the MEP has already also been incorporated and thought about. Now, in terms of material, just to explain you a bit the impact of the process itself. So the idea is to do testing that everybody is very familiar in construction. We do compression test, flexural test, for example, and we also are modeling these elements. Now, whether you print or whether you actually cut an element and you have the printing in different directions, well, that unfortunately has still today some impact, becoming less and less, and we are mastering more and more the behavior of these elements. There are quite a lot of research ongoing still, but just you need to be careful on the characteristics that you are using within your design. Now, this is just an example that we have done here for the project, and again, the tests that we are using are worldwide known. We have used the classical ASTM test. The idea was just to try to get an understanding between the announced resistance and what we were getting while or after printing, let's say. And you see that on the compression, there is some differences. Obviously, on the flexural tests, depending on the printing directions, you also have some differences, but it helps you to master basically the pieces and to master the design itself. And you can then agree on what are the parameters that you are using within your design. And at the end of the day, that demonstrates enough to get a certain approval. So that's the whole path we've been. I'm going quite fast. I'm sorry for that, but I don't want to go into too much details. I'm sure that if you are interested, we can talk about it. Now, the next step comes in, and that's very important. You need to deal with someone that knows the details. Some of the elements, like the slab, it's much more difficult to print. There are some research on printing slabs, but this specific project has been done with a classical slab that we had to connect to the printing element. So you need to work out your details. You need to work out specific elements. Think about lintels, for example. Think about your splicing between the pieces to try to understand where you go. If you are using a gantry, it's a bit different. You have some specific formwork you get and you just print on top of it. But this is also where you can control that you are dealing with people that know what they are talking about, is when you have people looking into material, looking into testing, looking into details, and showing you on drawings how it works. And that is very important. We have pushed it a bit forward on this one, having a test to demonstrate also to the client the visual, but also to demonstrate here the capabilities. And again, we had some materials. We've done this with Sika, and let's say some of the material for the joints have also been discussed and developed in partnership with our material partner. So this is the end result. And I think as per the first client request, needed to stand up, and I think it does. It is the first in the region that is fully load bearing and approved, and it's soon going to be open to public to be used. And you see also the details inside that have been quite well done. So it's, for us, one of the examples. I showed you others. I'm sure that every project has his benefits, but it's just to demonstrate you the whole path of how you get from an intent and an idea until the end of the project. Now, one of the major points I told you about that was differentiating the traditional and the 3D concrete printing was the lack of regulation support. Now, in the region, we have that push that has been, as I mentioned earlier, started by His Highness Sheikh Mohammed, and he has recently, I think it was in August, also pushed a decree forward to try to regulating the use of 3D printing in the construction sector. And they have tasked Dubai municipality to look into this. So it becomes more than just say, they are really pushing the technology forward. On top of that, you start to have work groups that are linked, for example, with ASTM. You have the joint group, which I'm also part of, but is led by Stefan, that is really trying to bridge the gap between our construction practices that we are today familiar with and the construction linked with 3D printing. What we want to avoid is to have people basically having just 3D printing done without the thought on the construction process, on the material, and have failure basically at the end. So our knowledge of the construction industry can really be brought into this technology. Another one that is quite interesting is the stamp from Underwriter Laboratory. So they are working under the UL 3401 to try to get a validation of your 3D printing process overall. It's kind of a standardization, but this is really important to push forward the technology and to hope to give the chance to everybody to get something certified and something that at the end of the day can be constructed. So I'm reaching the conclusions. I hope that I've been able to show you how the community has grown quite a lot, how the partners are still the same and new partners coming in, even having passed the trough of disillusion, as I call it. The processes have improved, the knowledge, and if you look online on research, I invite you to go to see some PhD developments in Ugent, in Leuven, in Zurich, and I'm sure that there are plenty in Germany, and probably even in the region here, I've seen some research. So this is really booming. And a big one that is extremely interesting, I believe, is that the business models from these different partners have been now more clarified. So you have engineering, you have people that are specialized into telling you, I can calculate your element, I can print your element, and I have the software to be able to demonstrate that this is printable and that it's going to take the loads that are coming. Then you have printers development, where people like Cobot, for example, are focused on developing the printer itself and selling it to you. So their business model have become clearer and clearer. On the material development, you also have, as I mentioned, some partners that are starting now to have a very clear, streamlined idea of where they are going to support these projects. And then you have others, and I think BESIX 3D is more linked with the last one, is more of an EPC mindset, where with our support from the mother company, which is a main contractor in the region and worldwide, we are able to get all these steps for one project from the engineering, helped sometimes with partners like with the vein. We have our material, helped sometimes with other partners, sometimes like BESIX, and we can demonstrate the whole step until the final construction and the ideas we want to deliver offshore, for sure. So I hope that you've realized that it's also answering some real societal issues as sustainability. And I think it's quite important, because this will be pushed more and more, and construction industry has to move towards these. And it perfectly fits with digitalization. Digitalization, Industry 4.0, has been also in the air since a few years, and everybody recognizes it's a must. Well, this technology, being also computer-driven, is fitting perfectly within these prospects. We have today, as I mentioned, second generations, but really proof of concepts in different markets. So not only housing, but you've seen a lot of different applications, which I think start to become quite interesting. And the regulation is on the way. I think everybody now understands that without regulation, it's not going to work. And there are quite some work groups that are really focused onto getting on the market things to make sure that we are going the right direction. Now, just to end, I promised you to talk about tomorrow. I think the tomorrow was already part of the conclusions, but we need to avoid the same big mistakes. I think education of the market, to be honest with what we can achieve today, knowing that the future is bright, is quite important. And there is no shame into starting small. You don't need to construct a full mall, or you don't need to construct a full building in 3D printing. Why are we not starting with elements, with the entrance, with some walls, with some lost formworks, with some shapes? I think this thinking needs to rise, and there is absolutely no shame into pushing for this. I hope that soon it will become just another equipment on a normal site. You will go to a construction site and you will see at some point a printer that can print elements, or that is printing a small part of it. It's not rocket science, really. We need to be very careful, and we need to have quite some knowledge, but at the end of the day, we know construction, it's cement, it's a robot, it's a mixer, and it's engineering. So we are able to adapt it for normal site. One of the big problem, obviously, is the lack of reinforcement. Concrete is not able to take tension, or very limited, but there are in place today some reinforcement strategies, some people looking into this since a while. And we have horizontal solutions, we have vertical solutions. We are thinking about how to get that more clear on the market, but it's ongoing. We are also thinking about limiting the cement into the mixes. So the noble goals are really still there. I think that bringing that technology with others is also a better way to try to reach the goal. And I see it working with other materials, and I see it working in a modular mindset. You can use really your imagination. I mean, we are used to do construction in the same way. You've seen with Zaha Hadid architects, you've seen other cases where people have ideas. And I think, you know, why not? Maybe it's too early, but at least if you find the right people, they will tell you it's too early. But why not trying? And that's my last word for today. I think we are talking a lot about houses. We are talking a lot about elements, about construction of buildings. I am certain that there are other cases where this will come handy, where we are using mass concrete. There are major developments of mass concrete in marine, for example. And I am sure that soon marine will come up into the system. And you know that NASA is pushing the technology quite a lot to think about how we can bring robots to the moon or even to Mars. I'm going to end up on this. Thank you so much for your attention. And I hope that I've been able to enlighten you a bit. And I will see you, I hope, at Expo 2020. If you are in the region, it promises to be an extremely interesting time where all the countries will be together. So don't hesitate. It is the end for me of the presentation, but you have my name, my contact, and please feel free if you have questions. I saw some questions coming in, but I didn't have time to reply. So voilà. Thanks a lot.
That's excellent, Ben. Actually, we have insight of 3D overall, you know, but the, you know, particularly the case study, you know, it's really interesting, you know, what is exactly required and what the engineers has to think. Yeah, I think there are some questions. I'll just read out, and I think you will be better equipped with the answer. So there's a question from Nishita.
Yes.
How the placement of reinforcement? What are the ductility behavior of concrete? Any codal provision? I think yeah.
Yes. So for reinforcement, obviously you cannot place reinforcement as you would do in a normal concrete. And that has been a bit the difficulty, because the printing path has to be continuous for the piece to start to be alive. And today you have to place reinforcement, but you don't know exactly what is the bonding system. You don't know exactly the anchorage that you need. So today we are not calculating 3D concrete printing as a reinforced material. And the reinforcement strategies that I've mentioned a bit earlier are not as our reinforcement mindset thinking. For example, these are combined with pre-stress. Pre-stress is very easy to understand, and that's a very classical design as per code, where for bridges, for example, you have concrete 3D pieces and the pre-stress is coming inside. But in terms of new strategies, some people are looking into vertical, so it's just an idea of puncturing the pieces with a rod to try to link all the layers together and get some tension into the piece. But this is today still not something that you will see tomorrow, a wall 3D printed, reinforced and calculated as such.
There is a big question from Mr. Akhilesh, Mr. Balakrishna. Again, you want to build a building of 5 by 8 meters, you know, in plan and 3 meters high.
Yes.
I think
Yes.
the same case study, I believe, whatever you explained.
Yes.
In that scenario, how the connection or integrity with the foundation will be done, you know?
Yeah. So to answer, that's a lot of question, Akhilesh, but to try to answer one by one. So the design, I think I mentioned it. You can revert to ACI, you can revert to Eurocode for mass concrete, for plain concrete, sorry. The software analysis, well, you have your classical softwares, but again, the stresses and the stress path that you get within your software result, you need to be quite careful. I think what we have tried to do in some elements is to use Diana, for example, where you have a better understanding of your concrete. Now, to build a room without reinforcement, yes, as I mentioned it, the one that I showed you, the case study, is without reinforcement within the walls. Obviously, for the seismic action, you have a diaphragm slab that is connecting all the walls together at the top. And basically, the system is just dowels connection. So the pieces are printed where at the top of the piece, you inside have a lost formwork. And in there, you come and place your dowels, and then you cast the dowels together, and that connects the whole system together. This on the foundation is just considered as a hinged system, and it works in shear with shear walls. I think, yeah, it would take more time to go into details, but that is what it is. The ink used for printing or the mixed, is it open source? Well, it's not ink. It's cement mortar mixed. It's not open source. It is provided by, as I mentioned, you have Sika, you have others, you have Laticrete, you have Weber, Saint-Gobain, you have Lafarge. So you have some providers of these materials.
Yeah, question from Mr. Dilawar. I think this is a general question. I think, can you do 3D printed building in seismic area? I think it's the same question, I believe. Yeah.
Yes. Well, you are applying the codes. So the answer is yes. But obviously, in our example here in Dubai, the seismic actions are not really high. We all know it. But yes, you have some houses. But again, in terms of full building being 3D printed, you don't see major systems. You are limited still today to one level and some size. When you go further than that, then you have to add the traditional within the printed element. So how it works, you have a shell, and then inside you still have some reinforcement and traditionally concreted, and that is basically your support system against your seismic when your building is getting too big.
Yeah, a question from Mr. Rajesh Kumar. What about slab or roof casting and printing, and what can be the maximum span that can be printed? I think, yeah, slab cannot be 3D printed, correct? That's what you told.
Correct. So you could think about, I mean, you are printing horizontal elements as the bridges, right? The way it works is you are printing elements that you are connecting to each other, and then you need to use pre-stress or post-tension. And that is still, it's a bit the idea of the Dubai Future Foundation also, but that is still linked with your traditional way of working and pre-stressing or post-tension.
Okay, good. A question from Mr. Madhu Narasimha. After 3D print, can you make an opening in the?
Yes, that's actually a very interesting question because I forgot to mention that. But the 3D printing elements, we can very easily do cold cutting into it, grinding, for example. And if you look at the pieces or the pictures I showed you for the buildings, well, all the recess for all the MEP, you know, your lighting switches, your pipes, whenever it comes, once you are within your building, you can actually cut easily inside your 3D pieces. It's not a problem at all. And, you know, like I show you the Expo one, the one I'm sitting on top here, you see the bottom, I don't know if you see, but the bottom has been completely also cut to be able to place the lights below. And you see it's a clean cut and there is no difficulty into cutting pieces. The facade also, yeah, the facade also has been cutted. So remember the GRC type facade elements? Well, they are printed in 8. And we are cutting the pieces every time, and it's a process that we know.
What is the software you use for the 3D printing? Is it proprietary or the? So
the software, correct. So the software it's linked with parametric, right? So you can use Rhino, you can use Grasshopper, and basically within these softwares, you are having a specific software that is helping you to show how the robot will work and to also slice the pieces. So you are modeling into classic model. It can be even in AutoCAD. And then you are putting that into Rhino Grasshopper, and within your parametric software development, you can slice up the pieces, and then you can have a direct visual on how your robot is going to function.
A question actually, what is the cost of the printer, and can you put on some commercials? Again, this is my question actually. Cost of the printer as well as commercials, like square meter, how much it costs, is it a costly motor, or how it works? Again, pricing.
Yeah, so that's a very nice question. So again, it's a tricky question, and I think that's part of the things why people have been sometimes also disappointed. If you compare a classical house, very simple square house, the 3D printing today is still more expensive. The cost of concrete material, let's say, it's about 2-3 times the normal cost for an element that in terms of volume I'm talking about. Now, you are putting less volume, but it also depends on how complicated your piece is, because if you have a piece that is very complex to do, well, then it's not the cost of the material in the traditional that comes in, is the cost of your formwork, or is the risks that you are not able to actually cast that element. There are properties within the 3D printing mortars. I showed you some overhangs. I showed you some shapes, some curves. All of that has been developed specifically, and that's why it is more expensive. Again, it is a new technology. I think the printer is not very expensive. If you talk about a robot arm, if you try to get a gantry system, it becomes quite expensive. But again, the idea is not to print one time. So it all depends on your depreciation of your material. It's basically like a crane, Sama. It's if you have to use a big crane for one house, well, yeah, that's gonna be extremely expensive. But that's a bit the mindset. So again, if you are asking to do a very small house, square, unless, like I showed in Icon, you have quite a few where your gantry can actually slip from one to another, it's not going to be economical today. But we have seen quite a reduction in terms of cost of the material. We have seen quite a reduction of cost also on the robot. The robots we are using, they are coming from another industry. They are coming sometimes of ABB or KUKA. They are coming from the automotive industry. You see all these robots working for automotive, well, you can also get one. So yeah, it depends. It depends.
Yeah, in principle, I think there are a lot of questions from the audience. I think since the technology is evolving, there will be many questions. So is it okay for you to share the mail ID or your contact details?
Yes, of course.
You can read. It's not there on the slides. And
no, it's not there, but I will. You know what? I will write it down in the question and answer.
Yeah, that's very good.
Chat, right?
Okay, excellent. That please post that. And the second point is, will you able to share the slides, or is confidential?
No, I will share it. I will just remove once or twice, one or two projects that have not been announced officially yet in the pictures. But the rest, yes, I will share it with you, Sama, so you can spread it around.
Please. Yeah,
for sure.
That will be excellent. And I'll take only one last question from my side. I think we are almost reaching 8 o'clock. Did you try it with the UHPC or fibers in the concrete, so that I've seen the suspended slabs taken by in the fibers, steel fibers, so that tension strength of the concrete can be increased drastically without reinforcement. Did you study on that angle, or that's?
Yes. So as part of the reinforcement strategies I talked to you about, the fiber is one that is pushed since the most time, actually, because this is something we are also familiar. The problem with the fiber is that you change the way the concrete goes through the hose to the robot. So, the difficulty here is that you have a certain speed and your material needs to harden at a certain speed to be able to accommodate the next layer. When you put fiber into it, the behavior of the material obviously changes a bit. Also, you are putting fiber in the material, but at the end of the day, you put fiber in the layer and you don't have fiber in between the layers.
Okay.
So there are complexities within this, but there is a PhD ongoing that I'm aware. I'm pretty sure there are others in TU and Leuven that is really looking into different type of fibers to make sure that we get also that interconnectivity between the layers and that printability that is not changed.
I think that's the end of our session today, and thank you again, Mr. Ben, for your time, valuable time. I'm sure you have a 3D lab or research lab. Soon
Yes.
we're going to meet you. I think
so anyone who wants to visit us, we are in Dubai and we are in Alcoz, and the studio printing is open. It is really for us still an open innovation. We are sharing, and I'm very happy to share. I think having people getting more and more updated with the technology is the most important thing that needs to be achieved, so that we don't get back into these fake news. So we are open. Anybody can visit, and we will be happy to show you around. I have sent my contacts, so you can take it, and definitely I will be happy to have further discussions. Me or my colleagues that will be able to reply to you.
Thank you, Ben, and thank you all good attendees today. Actually, yeah. Good night.
Thank you. Night.